This is Mr. Alexander, and today I'm going to talk to you about basic set theory and shading of Venn diagrams, which is part of topic 3, which is the logic, sets, and probability topic. Let's talk about basic set theory for a moment. It says, let U, which stands for the universe, be x's such that the x's are between 8 and 13, not including 13, and they're natural numbers. Natural numbers are just the counting numbers starting with 0. So the universe is simply 8, 9, 10, 11, and 12. That's the whole universe. It's those 5 numbers. Now, P is multiples of 4 within that universe, so that would just be 8 and 12. And Q are factors of 24, which are numbers that multiply to 24, so that would be 8 and 12 as well, not 9, 10, or 11, because none of those can be used to multiply to 24. And R is square numbers. I like to call them perfect squares, so like 1 squared, 2 squared, 3 squared, 4 squared. 9 is 3 squared, so that's the 1 squared number in there. So those are my sets, and forgive my brackets. List the elements of U. Well, I already did that, didn't I? It's just 8, 9, 10, 11, and 12. That's all the elements of U. And then B, we're drawing a Venn diagram for P, Q, and R. And here's the universe right here. It's that rectangle, everything that rectangle. Now in that rectangle we've got 3 sets. We've got P, which are the multiples of 4. We've got Q, which are the factors of 24. And we've got R, which are square numbers, or if you prefer, perfect squares. Now we want to write the elements in there. And I'm just going to go through the numbers in the universe, all 5 of them, one at a time. So I've got an 8. Now I can see that that 8 belongs in P and Q, but not R. And the section that's P and Q but not R is right here in this intersection right there. That 8 belongs right there. And let me zoom in on this so you can see a little bit better. 9 only is a square number, so it only belongs in R. It doesn't belong in either P or Q. So I need to put that 9 with just the square numbers, which are right there. 10 is not in P, Q, or R. So 10 is in the universe, but it's not in any of those circles, so I can just write it anywhere in the universe. I'm going to put it right there. It's outside the circles. 11, it's the same thing. I don't see 11 in P, Q, or R, and so it's in the universe, but it's not in the circles. So I'm just going to write 11 over here. It's in the universe, but it's not in the circles. The last number in the universe is 12, and 12 belongs right, let's see here. I see it in P and in Q, so I'm going to write that 12 right there. So there they are, 8, 9, 10, 11, and 12. That's all of them. And there's my Venn diagram, part B. So in part C, I'm trying to list the elements in P intersect R. And hopefully you can see that the intersection of P and R, I've got no numbers written there. And so as a result, that's just the empty set. In part 2, I'm listing P, not P, intersect, Q intersect R. So not P is everything outside this P circle, so I'm just going to cover up P. Q, there's nothing in Q at the moment because I've got the only stuff that's in Q I've got covered up. So there is no intersection. Intersect with R. So I'm really just talking about this one little section right there, and there's nothing in there. So that's also the empty set. So there's nothing in those. In part D, I want to describe in words the meaning of set P union Q. So D, P union Q is the set of numbers which are either, because the union could be one or the other or both, which are either multiples of 4 or factors of 24, or both. That's what the union means in words. And the last thing we're supposed to do in part E is shade the region on your Venn diagram that represents P union R intersect Q not. So I'm going to do this. I'm not actually going to do it in this diagram. I'm going to draw a separate one because I'm going to make a mess here. So here we go. I've got my universe right here. Got my P. Got my Q. We've got my R. And I always start with the parentheses. So I want to do P union R intersect Q not, or Q complement. Let me just zoom in on that. There's my whole universe. I always start with the parentheses. So P union R would be all of the R circle and all of the P circle, just filled in. So imagine that these two circles are all filled in, all the way. And then ask yourself, where does that intersect with not Q? So everything outside the Q circle. Well, that would just be all of this stuff here. And the way I want you to think about it is, where does the overlap occur? So think about the way that I just thought about it. I filled in my mind, I filled in P union R. I got all of P and all of R. And I asked myself, where does that intersect with everything that's outside of Q? Well, it's just this stuff here. So think about the overlap. If you have to draw two separate pictures, that's not a bad idea. So I might draw P union R in one picture and draw Q not in another picture and see where they overlap. Imagine yourself putting them on top. And that's a good segue into the rest of what I want to do here. I want to do some more shading. I'm going to do a few of these here. I'm going to do a union and an intersect from each one of these. So let's just start with A, because that's a union problem. P union Q not. With unions, you should just do one piece. Go ahead and shade in all of P, because the union is everything stuck together. So I'm going to shade in all of P. And then I want to do the union of Q not. So then I want to shade in everything that's outside of Q. We already got some of the stuff that's outside of Q, this P circle, but then there's a whole bunch of stuff that's outside of Q as well. In fact, it's everything except for this little crescent right here. So the only thing that's not shaded is the crescent part of Q. Let's do an intersect problem. So I'm looking at D right here. Not P intersect not Q. Well, not P is everything outside the P circle. So imagine myself filling in everything outside the P circle. And then not Q is everything outside the Q circle. If I was to do that, which part is shaded twice? Well, the part that's shaded twice is just all this stuff on the outside here. So it's everything outside of the two sets. All right, let's look at a slightly different Venn diagram, and let's do the same thing. Let's do one union problem and one intersect problem. So the union problem I want to do is, let's do this one. F. H union not N. So I'm going to go ahead and shade in all of H, because I know with unions I'm just going to stick it all together. And I want to add to that everything that is not n. So everything outside the n circle, which is all the remaining stuff. So what you probably can see here is that I've shaded everything. So in part F here, we've shaded everything. Now in the intersection, let's talk about B. H intersect not n. Well, what's H? Well, it's everything inside the H circle here. Imagine myself filling it in. And what's not n, or n complement? Well, it's everything outside the n circle. So I'm not shading it, but I'm imagining myself shading it. Which part would I have shaded twice? Well, it's everything inside of this H circle that's outside of the n circle. So it kind of looks like this. It's that stuff. Let's go through these and do two more. I'm going to jump to the question 6 here with the 3, because if we're going to do this on the IB exam, there's probably going to be 3 circles. Let's do one union and one intersect. So I'm going to do A and B here. So A union B, union C. This is a union problem. So I know that I can go ahead and shade in A union B, because I'm just going to be adding to it. Question is, what do I add to it? Well, I'm going to add to it all of C. So essentially, A union B union C is just all 3 circles added together. What about this one? This is an intersect problem. So I'm going to imagine myself shading twice. A union C is all of the A circle, all of the C circle, and I'm going to ask myself, where does that intersect with circle B? Well, that's just this stuff right here. And I like to outline it so it's clear what I shaded. I've got time, so why don't I do a couple more like that? I'll do this union problem right here. A union B, union C naught, or C complement. Since it's a union, I'm going to go ahead and fill in A union B, because I know that whatever it is, I'm just adding to it. And the part that I'm adding is not C. So I'm going to shade in everything that's outside of the C circle. So essentially I've shaded in everything except for the little crescent part of circle C. And I like to outline that so it's clear what it is that I have not shaded. And let's do one more intersect problem. I've got A intersect, not B intersect C. All right, so this is a tough one, so let's think about this. Not B, which is everything outside the B circle, intersecting with C would be these 2 regions right here. Where does that intersect with A? Well, it's just this one region right here. So it's just this one little sector in this part. Okay, that's all I have time for. So thank you for watching. We'll see you next time when we talk about 2-dimensional Venn diagrams for problem solving.